Hello guys, in this video we'll be considering the concept of object-oriented programming. Welcome to another lesson in the Python Programming for Beginners series. Talking about Python object-oriented programming. For now we are going to cover the basics of object-oriented programming and why do we need object-oriented programming. By the end of this video, we have a solid understanding of why object-oriented programming is important. So most of the times, if I need to talk about or if I need to mention object-oriented programming, I might just refer to it using OOP. I think object-oriented programming is kind of long and might be hard to pronounce along the way. So let's start simple. What is OOP, that is object-oriented programming? In all of our previous examples, whenever we want to perform any operation, we mostly group those operations using functions. You can define just a simple function to perform a simple operation, or you can define multiple functions to perform series of operations. This approach in programming is called procedural programming. To some extent, this kind of approach is alright, but when it comes to complex programming, the procedural approach to programming tends to spiral out of control, and it becomes harder to manage. Because of this, it becomes essential to adopt a better and robust approach to programming, which leads us to object-oriented programming. In Python and many other programming languages, we use object-oriented programming to organize our code. This is one of the core strengths of OOP compared to the procedural approach. It's just like sorting all your files into folders instead of having everything thrown around in one place. OOP lets us group related data and actions into a single unit called objects. Just like in real life, an object can be anything. It can be a car, it can be a phone, it can be a computer, or it can even be a person. These objects have characteristics or properties and they can do certain actions. For example, a car has a color, it has a model, or it even has a specified speed. And a car can also do certain things like drive or stop. Just like in real life, in OOP we do the same thing in code. We create objects that represent things. We give objects some properties, and these properties in programming are called attributes. And we also define some actions. In programming, we call these actions methods. So why do we need OOP? Why do we need to bother? Can't we just write everything in one place like we used to do in normal procedural programming? The thing is, you can as well write your code without using OOP approach. But as your programs get bigger, things can get messy really quickly. Imagine you are writing a code for a car rental service and you've written like 50 different functions and variables scattered all over the place. It becomes hard to keep track of everything. This is where OOP comes in. It helps keep things organized and make your code easier to manage and understand. So let's break it down. OOP helps you to bundle everything that belongs together in one place. Instead of writing random bits of code here and there, you group them together inside of a class. That is what brings about the concept of organization with OOP. We talked about objects, that object contains attributes and methods. So you use a class to create objects. We can liken a class to architectural plan. Before you build a standard house, you need to create a plan. You contract an architect or a structural engineer to help you draft a plan. The plan contains the details and the layout of the house you intend to build. Same can be said for a class. A class defines what data the object will hold, which we call its attributes, and what actions the object can perform, which we call its methods. So for example, let's say we want to create cars as objects. Just like we already know, we use class as blueprints to create objects. So what we need to do first is to create a class as blueprint for our intending cars. To create the class, we use the keyword of class and then the name of your class. Now we are creating a car class. Okay, so after that, we have a constructor function. Don't worry about the syntax for now, we'll deal with that in our next video. I just want to have a good introduction to OOP and why we need OOP. So your car has a brand and it also has a year. So inside of your constructor function, you have self.brand to be equal to brand. Okay, and you also have self.name to be equal to name. I mean year, that's name. Now we've defined a class for our car. This is the blueprint with which we are going to create the car objects. So this is supposed to have a colon, it's a function. Okay, so to create an object out of this class, now all you need to do is, we've defined your car. So all you need to do is, let's say, we want to call this my car as the name of the car object we want to create. Okay, so we are going to initiate the car class. So with this now, by initiating this class, we've created this my car object, and the car class is looking for two parameters, which is the brand and the year. So we can say the brand is, let's say, Toyota. I think Toyota is a popular brand for cars. And then the year, we can say the year is we can say 2023. Okay, so if we print the brand of my car now, let's use the print function. We can say my car dot brand. Let's run this and see what we have in our console. So you see that the brand of my car is Toyota. We can also print the year of my car. So we have print my car dot year. Let's run this again. What do we have? So we have Toyota as the brand of my car, and we have 2023 as the year of my car. So in this example, we created the class called car, and it has two attributes. The first attribute is the brand, and the second attribute is the year. So from this class, we created an object called my car. So my car now is an object. You can as well print my car and see what we have in our console. So we have print my car. If you print the whole of my car, what do you have? So you see you have objects. From this class, this car class, we created an object called my car, and then from my car we can access all the attributes, the properties of my car, which is brand and year in this case. So this is one of the benefits of object-oriented programming. It helps with organization in that it helps you to group your code in a single place. Another reason why object-oriented programming is great is reusability. Imagine writing code for a game where you need characters like warriors, police, gangs, and the likes. With OOP, you don't have to write everything from scratch for each character. You can just define a basic blueprint, which is a class, and then create multiple characters from that single class that you've defined. So, for example, just like we have this car class as an example, we can create multiple objects from this car, so we don't need to create multiple classes for creating the car objects. For example, you want to create another object, possibly we can name it your car. We can comment this out. So let's say we want to create another car, we can call it your car. The first one is my car, so now we are creating another one as your car. So all we need to do is we call the car class, and then we pass the brand and the year. So we can say this is Chevrolet. And the year, we can say the year is, let's say, 2020. Okay, so we can also print the brand and the year of your car. If you print this now, you can say your car dot brand. You can also print the year of your car. So you have your car dot year. If we run this now, so you see the brand of your car is Chevrolet and the year is 2020. With this single class, you can create as many objects as you want. That is the concept of reusability. You can create 1,000 cars from this single car class. Another reason why OOP is great is it helps with abstraction. Abstraction means keeping things simple by hiding the complicated details. For example, when you use your phone, your phone is another example of an object. So you don't need to know how every single part of your phone works. If you want to call your own, it's just to open your dialer and then dial the number. You don't need to know the details. You don't need to know how your phone connects to network, how it transmits from one mast to another. So object-oriented programming helps you in hiding these complicated details. You don't need to know every single part. You don't need to know how it works. You just need to, for example, in case of your phone, you just need to press the button and it does what you need for you. So in OOP, abstraction also works in this same way. You don't have to worry about the complex inner workings of objects you are using. You only need to know how to interact with them. In Python, this is done naturally by using methods, which is the second major part of an object. The first part is attributes. The first part of an object is attributes. The attributes are the properties and the characteristics of those objects. But methods describes what your objects can do. A method is modeled with a function, just like your attribute. Your attributes are modeled with variables. But for methods are modeled like functions. For example, let's say we have a calculator class. Can comment this out. This is your car. This is car. We comment this, and the car class, let's comment this out. So let's say we have a calculator class. We have class, and then we have calculator. So inside of the calculator, we want to define a method, and just like I said, methods are modeled in the shape of function. So in the calculator, we want to define a hard method. So the hard method is going to take in two parameters. That is the first and the second number that you want to add. So we can say the first number is A and the second number is B. Okay, here we need to return A plus B. Now to use the method that is on your calculator class, you need to first call your class, which is the calculator. So we are calling it and assigning the objects to calc variable. Okay, so now you can perform an addition operation using the method that has been created on the calculator class. So you can say, let's say we can call the results summation. We can say summation is equal to calc dot add. Add is a method that is available on the calc object because calc is created from the calculator class. So we want to add two numbers. We can say the first number is 3 and the second number is 5. Okay, so let's print summation. Print summation. Okay, let's run this and see what we have. We can click this terminal. So we have a fresh terminal. And drag this up. Okay, so we run into type error. In the add function, we need to add a self parameter, which is referring to the object that will be created from this calculator class. We run this again, so we see 3 plus 5 is equal to 8. So as you can see in this example, you actually don't need to know how the add method works. Even though we are the one that defined the add method here, this is just a simple illustration of how OOP helps with abstraction. You actually don't need to know how the add method works. The calculator class can be imported from another module. Possibly you install a package from the Python package platform. You don't necessarily need to know how the add method works. All you need to do is to just create a calc object, a calculator object from the calculator class, and you call the method and pass in the required parameters, and it's going to perform the operation for you. So that is how OOP works with abstraction. Another benefit of OOP is inheritance. Inheritance means that you can create a new class based on an existing class. The new class will inherit the properties and methods from the old class. This allows you to reuse code and new features without starting from scratch. So we can see that in example. The inheritance advantage of OOP, you actually don't need to always create a new class from scratch. you can create a new class on an existing class. So let's say, for example, we have an animal class. It's animal, okay, and inside of animal, you have your constructor function. So this is supposed to be init. You have self, and your animal, you want to give it a name attribute. So inside of the constructor function, you have self.name to be equal to name. That is the parameter you'll be passing whenever you want to create a new object from the animal class. So from this animal class, now you can create another class, possibly a dog class that is built upon this animal class. So to build another class on top of this class now, all you need to do is, okay, we are supposed to have a colon here. So it's a function. So we are going to create another class and we call the class dog. So we are building it on the animal class. Now we are going to pass in the name of the parent class. What we are doing now is called subclassing. So inside of the dog class, we can create a method. Let's say we can call it speak. Okay, we have def, we have speak, we have the self keyword. Okay, so what we are going to return, we are going to return an f string, self.name args. So in this example now, we are creating the dog class on the parent class of animal. As you can see in this dog class now, we don't need to create another constructor function. This init function, we don't need to create it because this function has already been created on the parent class, which is the animal class. So we don't need to recreate that. Now because we are creating the dog class from the animal class, the dog class is going to inherit all the properties and methods that are already defined on the parent class, which is the animal class. So that is the concept of inheritance. Now if you create an object from the dog class, so we can say, can call this my dog. We want to create my dog object from the dog class. So we have dog, and what is dog looking for? Dog is looking for the parameter of name, because dog is inheriting this from the animal class. So we can call the name of my dog, let's call it can say James. If you are bearing James, don't be annoyed, that's just the name of my dog. Alright, so now we've created the object of my dog. So if we call on the speak method on the my dog object, so if we have my dog dot speak, that's a method that is available on the dog class. Okay, so if we run this now, alright, let's print this. We don't have anything in our console because we're actually not printing anything. So let's print this and run it again. So you can see that James barks. Actually on the dog class, we actually don't have any attribute of him. But because dog is created from animal, so dog is inheriting all the attributes that are already defined on the animal class. That is the concept of inheritance. Object-oriented programming helps with inheritance. You actually don't need to recreate everything from scratch. If you have a class that has some attributes that you need in a new class you want to create, all you have to do is to create your new class on the previous class. So the new class is going to inherit all the properties, the attribute and methods from the parent class. Alright, the last thing we'll be talking about as the benefit of OOP is polymorphism. Object-oriented programming allows objects of different types to be treated the same way. For example, let's say you have different types of animals that are created from a parent class. Let's say you have dog, goats, cats that are created from an animal parent class. They might all have the same method, let's say speak, but all these animals, all these objects, they'll be behaving differently, even though they are created from the same parent class. We can see that in an example. Let's say we have the class of animal. We don't need the attribute of name, so we can get rid of this constructor function. So all animals speak, even though they have different method of speaking. Like a dog barks, a goat bleats, your cat mews, and all that. So we know that all animals speak, but because different animals speak differently, we don't need to write any code in the speak method since all of them behave differently. So what we are going to do is we are going to pass, because without passing it, we'll be running into function. VS Code is expecting that we write some code inside of this speak function. A function, we always have code. If there is no code in a function, then there is no need for creating a function. If you just want to define a function, you don't want to provide any code inside of that function, just use the pass keyword. That is going to allow your IDE to allow you to pass without writing any code, and you are not going to run into any error whenever you are executing your code. Okay, so we have the parent class, parent animal class. Now we have dog class, which is created on the parent class. We know that if a dog is asked to speak, then your dog is going to bark. Now we don't have any name attributes on the parent class, so we can get rid of this. So we can just return woof, which is how your dog barks. Okay, we can also have another type of animal. We can call it, okay, we can have goats. So let's say we have a class of goats. Goat is also created. Goat is a subclass of the animal class. Okay, so your goat also speaks, but it speaks differently from a dog. Okay, so whenever your goat is asked to speak, your goat is you are going to return. How does your goat speak? Sometimes it is bar, sometimes it is bar. Anyhow your goat speaks, let's just pick one. So let's say we have another animal. We can say cats. Okay, so we're also going to create this from the parent animal class. Okay, and whenever your cat is asked to speak, so let's self. Don't worry about the syntax for now. We are going to deal with that in our next video. And whenever your cat is asked to speak, your cat is going to say meow. All right. So the concept of polymorphism, we can have objects of different types to be treated the same way. Now that we have dog created from the animal parent class, if we create an object from the dog class, okay, just like we have my dog, but presently we don't have any attributes on the dog class, so we actually don't need this. We are not expecting any parameter, so let's get rid of that. Okay, so we can just call this dog, not really. Okay, so and if we have goats is created from the goat class. Okay, and we have cat is created from the cat class. Okay, so now we have different objects created from the same parent class. So if we print dog.speak now, we can also print goat and cat speak. We have goats and we have cats. Now let's run this. What do we have? So whenever dog is asked to speak, it speaks woof. Whenever a goat is asked to speak, it speaks bar. And whenever a cat is asked to speak, it speaks mew. We can see now that object-oriented programming allows objects of different types to be treated the same way. Just like the dog objects, from the dog object you can access the speak method, from the goat object you can access the speak method, and from the cat object you can also access the speak method. Even though, and as you're accessing the same method on all the objects, you are getting different behaviors. That's all we'll be having for this video. OOP helps you with organization in that it lets you group related data and actions in one place. It also helps with reusability, and that is, you can reuse your code, which saves time and effort. It also helps with abstraction, in that you can hide complex details and just focus on what's important. It also helps with inheritance. You actually don't need to keep rewriting all your code from scratch. You can build on existing code. The last one, which is not the least, is polymorphism. You can treat different objects in a similar way, which makes your code more flexible. So in the next video, we'll be looking into how to actually start working with object-oriented programming by creating classes and objects in Python. If you found this video helpful, don't forget to like and subscribe. Feel free to ask any questions in the comments below. See you in the next lesson.